Oh no, it's a small subwoofer. But then it's fast, right? A scientist may tell you that there are no fast or slow subwoofers. They are all slow because they cover only the lower frequencies. That's not entirely true. When we experience the sound from subwoofers and bus systems, we experience that they sound different. And some sound more sluggish and slow, while others are perceived as very transient and lively. So there is a difference, and we use the words fast or slow to describe how we experience the sound. So fast or slow, it is a thing, but it's not exactly that the subwoofer is fast or slow in a purely scientific or technical way. It's just that we use those words, fast or slow, to describe how we experience the sound. So what is it that makes subwoofers fast or slow, and can we fix it? So does it sound fast? It sounds quite nice, actually, and when I compare it to the larger models, I find that actually the larger ones sound faster in a way. And that is especially when I turn up the volume, I experience that the larger ones, they have a more sudden, faster impact on the transients. This can be explained because the larger ones, they have a higher output capacity. When I turn up the volume, this small one will clip or compress the transients. You can't hear it as distortion, but you can experience it as loss of impact and energy. Just keep the volume down, then this small subwoofer sounds equally fast as the larger ones. But from this experience, we can conclude two things. One, a larger subwoofer does not necessarily sound slow compared to a small one. And two, yes, subwoofers are experienced different in sound, and slow or fast can be two words we can use to describe those experiences and how we perceive the differences in sound. If we look into subwoofer drivers, we see that they are a little bit different from the drivers that cover higher frequency ranges. They have a very heavy cone, very heavy moving mass, and they have a very long suspension travel, so that the cone is able to move lots of air, because that is what makes sound at very low frequencies. You have to move a lot of air. The problem with this is that both the heavy mass of the moving cone and the long travel causes problems. If we want to move something that is twice the weight, then we can just apply twice the power, twice the force. Then it will move just as fast. Isn't that so? Yes, it is. But the problem is when we try to get more force out of this motor system that drives the cone from here, then we get increasing problems with non-linearities, And those non-linearities, they tend to be worse at higher frequency ranges. So in the upper bass range, where this fast attack is on the subwoofer, it causes problems. It causes problems because we have a non-linear inductance in the motor assembly that increases when we increase the current, try to push more current, more and more, faster and faster current into the driver, but it can't, because the nonlinear inductance, it counteracts this and it obstructs the current so that we are not able to increase the force as fast as we would like to do ideally. Here I have a different driver. This is the driver that is used in those medium-sized or larger compact horn subwoofers. And this cone is much lighter than the other subwoofer driver. And the motor, which you can't see by looking at it, but inside the motor force from this motor is much higher. It's almost twice as powerful, this motor. It doesn't have quite so long travel of the cone, but the maximum mechanical excursion is massive. It's actually longer than the other subwoofer driver. So lighter cone, less movement. And that is a recipe for a faster subwoofer. The problem is, of course, that if you put this driver into a sealed box, you will not get any bass, low bass out of it. So that's why I have this acoustic loading in the compact horn subwoofers. Fixes that, so I can use a subwoofer driver that is fast and quick, responsive, so it works well in a higher upper frequency range of the subwoofer. And then we have the acoustic loading that loads the cone so that a small movement moves a lot of air. So I also get low bass out of it. That is one way to fix the problem. The majority of subwoofers, almost all subwoofers commercially available, they are some sort of sealed or ported boxes, and they have some sort of subwoofer driver that is similar to this one. It's a heavy cone, very long travel. And thing is, even with a long travel and a heavy cone, if you do a very good design of the motor system, then you will reduce most of the problems that you have with this heavy mass moving all over the place. So you can have a quicker subwoofer, and that is why some subwoofers can sound better than others, even if they are just simple sealed boxes with heavy cone drivers. Especially at lower frequencies, they can work quite well, and they are also very compact in size. When we exceed the output capacity of a subwoofer, then we get this compression of the transients at first, and this may be perceived as a slow bass. So how can we improve that? Of course, we can ensure that we have installed a proper capacity of the bass system. Yeah, we have to have enough capacity to be able to play as loud as we want to do. If you don't play very loud, then that small white subwoofer may be enough. If you play louder, you need something bigger. Output capacity is also relative to frequency. And what we often experience, if you have an insufficient motor design and a very heavy cone, then it will actually compress at higher frequencies. This means that such a subwoofer will have a lower usable capacity compared to one that does not compress the higher frequencies. Usually, the capacity limits of a subwoofer is determined by its displacement at very low frequencies. A subwoofer always has less output, say at 20 Hz compared to at 100 Hz. Because at 100 Hz the cone doesn't need to move much at all, while at the very low frequencies the cone needs to move a lot. So that was the subwoofer. The subwoofer in itself can be a limitation that limits how fast a bass system sounds. Then we have setup and calibration of the bass system, which is also required to be done properly if we are to have a subwoofer system that doesn't sound like it is slow. And the first thing to get right is to have a proper time alignment between the subwoofer system and the main speakers. If the sound from the subwoofers are delayed compared to the main speakers, then the bass may sound a little bit slow and delayed and sluggish. Not by much, it's something we will perceive mostly on transients, that where the attack and the transient has lots of energy in the region around the crossover frequency. And to fix this, we adjust the time delay so that we delay the main speakers compared to the subwoofer system. And this is done in a processor, in the DSP, with a delay in milliseconds on the main speakers, or distance on the subwoofer in the typically home theater processor. You set this properly and then we are good to go. If you have a sound system with no processing on the main speakers, the only thing you can do to improve this is to move the crossover frequency for the subwoofer system further down low. If you have a low crossover frequency, let's say at least below 80 Hz, let's around 60 perhaps, then if you have a few milliseconds delay on the bass system, it doesn't matter that much because the wavelengths are much, much longer. So the sound takes longer time. So a few milliseconds then, it doesn't matter that much. Then we have room resonances. Room resonance will affect the sound quite significantly. And a room resonance, which is highly undamped, will have this characteristic that it sort of builds up over time, so that it starts the lower amplitude and then the amplitude in the bass increases before it dies off slowly. And this is of course perceived as boomy and sluggish and slow bass. This can also be fixed. We fix it in DSP on the subwoofer. We find the resonance and we take it down. We eliminate it. And then there is the frequency response of the system. If we have a subwoofer that is born with a quite narrow bandwidth, so it rolls off quite early, so it doesn't reproduce so much high bass, and it also rolls off at the lower frequencies, so it can't reproduce the very low subsonic frequencies. So it has a frequency response more or less like this, like going up. So it's more or less like a sort of a quite wide peak. That's the frequency response. This is a recipe for a slow and boomy bass. This is because this response with this shape is sort of a resonance in itself, so it will be perceived as a resonance. The whole bass will be a resonance. So we don't want that. We can fix it. We adjust the frequency response in the DSP on the subwoofer so that we get a flatter response, and so that we can reach up to the crossover frequency in a proper way, and also we extend the frequency response flat a bit further down in frequency. A flat frequency response, wide and wide frequency response, is necessary to be able to reproduce a short time transient. Like this drum here is sounds like this, and with all the faults we have discussed now present, it can be something like this. So clearly there is such a thing as a slow or fast subwoofer, but it doesn't necessarily mean it's the fault of the subwoofer. It can also be the setup and the calibration. We can fix it. To fix the subwoofer, that is a bit more. If you have a subwoofer like this small T6, that is a very good subwoofer, but the limitation is that if you are going to play very loud in a space that is not very small, then you will not be able to get to a sufficiently loud volume to have this really solid chest impact. Then you need the larger subwoofers to get that. So a subwoofer, it has to be used as it was intended and designed for.